In this lesson, we are going to study the inverse functions. The purpose of doing this is to help us look at logarithmic and exponential functions. Those two functions are inverses of each other, so this is a skill that we will need to practice. And this is essential for helping us solve real-world problems involving population growth, radioactive decay, and compound interest. So objectives are to determine if a function is one-to-one, and if it is, find a formula for its inverse. And then we will simplify expressions of the type f of inverse f and inverse f of f, which are composite functions. And so when we go from an output of a function back to its input or an inputs, we get an inverse relation. And when that relation is a function, we'll have an inverse function. So to get the inverse relation, we only need to interchange the first and second coordinates of each ordered pair to produce the inverse relation. If a relation is defined by an equation, we simply interchange the variables to produce an equation of the inverse relation. So for example, consider the relation H that has the ordered pairs -8, 5, 4, -2, -7, 1, and 3.8, 6.2. For the inverse relation, we will switch the variables. So we'll call it H -1 is equal to 5 -8, -2, 4, 1 -7, and 6.2, 3.8. In example 2, we have the equation y equals x squared minus 5x. To get the inverse, we exchange the x and y variables, and we have x equals y squared minus 5y. If you graph both of these in your calculator, you will see that we have symmetry where the original equation y equals x squared minus 5x, that's in blue, that's the parabola facing up. And then there is the inverse, which is parabola, the red parabola facing to the right. Notice that we have reflection across the y equals x line. That's y equals x. And so for any point that is on the original equation, we can flip those ordered pairs and we will find it on the inverse. So for instance, for the point 2, -6 on the relation y equals x squared minus 5x, we'll go ahead and find 2, -6, which is down here. And then we can do -6, +2 on the inverse relation, which is over here. And so those 2 points are equidistant to the line y equals x, and they are reflective. So if you folded a paper over that line, you would get those 2 points. A one-to-one function is where different inputs have different outputs. That is, if A is not equal to B, then f of A equals f of B. Or a function f is one-to-one if when the outputs are the same, the inputs are the same. That is, if A equals B, then f of A equals f of B. So determine if the function is one-to-one. This is f of x equals x squared. Well, if we look at the second here, we can see that f of 4 is equal to 4 squared, which is 16. but f of -4 is also equal to 16. So here we have A is not equal to B, but f of A is equal to f of B. And so that fails that second part. So this function is not one-to-one. But we have other ways of finding out whether a function is one-to-one using the horizontal line test. So some features about one-to-one functions and inverses. If a function is one-to-one, then its inverse is also a function. The domain of one function is the range of the inverse, and the range of the one function is the domain of the inverse. A function that is increasing or decreasing over its entire domain is always going to be a one-to-one function. So note that if the inverse of a function f is also a function, it is named f to the -1. That's read f inverse. It does not mean 1 over f. Okay, it's just that -1 just means inverse. All right, so we can do a horizontal line test to see if a function is one-to-one. If you draw a horizontal line through the graph and it intersects it in only one place, then we can see it's a function. So in example 4, determine whether the function is one-to-one. The horizontal line is in red, and we can see that it crosses the graph in only one point. Therefore, the function is one-to-one. In B, we see a horizontal line going through 2 points, and therefore this is not one-to-one because it fails a horizontal line test. In the next, we're going to do some, in the next page, we're going to do some examples where we find the formula for the inverse. The steps are, 1, we replace f of x with y. Step 2 is to interchange x and y variables. Step 3 is solve for y, and step 4 is replace y with the inverse f. So for part A, we're going to go ahead and determine first if the function is one-to-one. Now, if you graph this, this is going to be a linear equation, so we know that this is always increasing, therefore this is one-to-one. Of course, you could get your TI-84 and graph it and do the horizontal line test. All right, so this is one-to-one. So the first step is to replace f of x with y. So we have y equals 3x minus 7. Interchange the variables. So x equals 3y minus 7. The next thing, step 3, is to solve for y. Let's see, I'm going to take the 3y and add 7 to both sides. So we have x plus 7. Then I'm going to divide by 3. So x plus 7 over 3. And then the last step is to replace y with our inverse x, inverse function of x. So we have f -1 x equals x plus 7 all over 3. In B, we have f of x equals x plus 3 over x minus 5. We're going to replace f with y. Then we're going to switch variables. And then solve for y. We're going to multiply both sides by the LCD, which is y minus 5. And we have x times y minus 5 equals y plus 3. Distribute the x, and we have xy minus 5x equals y plus 3. I need to group all the y's to one side. So I'm going to subtract y and add 5x to both sides. Distribute the y, we have x minus 1 equals 5x plus 3, and y is 5x plus 3 all over x minus 1. So replace y as our final step. Replace that with inverse of x, inverse function of x, and we have 5x plus 3 divided by x minus 1. And that is our final answer for the inverse function. In the next problem, we have f of x equals x cubed minus 5. So we replace f of x with y, switch variables, solve for y by adding 5 to both sides. We take the cube root of both sides. And so y equals the cube root of x plus 5. Last step is rewrite f negative 1x equals cube root x plus 5. And then our last problem is f of x equals the cube root of 7x. All four of these are functions. If you graph them on your calculator, you'll see that it passes the horizontal line test. Replace f with y. Switch the variables. And solve for y. So we're going to raise both sides of the equation to the third power. So we have 7y equals x to the third. Divide by 7. We have y equals x to the third over 7. Replace y with inverse f, and we get x cubed over 7. And that's our final answer.